and say it's a B or a C. Well, you can't use that either. Oh, wait a minute. You could. Well, interpret these to mean that you just get splitting. So let's start looking at the Q3 or the Q5. Now because you're using non-determinism, you've got a branch that way and a branch this way. If you branch that way, the machine that's in Q3, it's now checking to see if the number of B's is equal to the number of A's. Okay? And if you branch this way, you're going through the B's, but you don't care about their number. And at each step you make a copy, right? Because you've got 3 of these epsilons here. So you don't really care about the number of B's, but then you make a copy each step, and then you get into Q6, another state, and now you're checking to see if the number of C's equals the number of A's. And you do that in the same sort of way as you did with here. You just keep popping the stack each time. And if when you finish reading the input string and you repop $1 on the stack at the same time, then you know there's a match. The I equals J or the I equals K. You're using the same sort of trick, same sort of logic as in this case. All right. Well, let's do the simpler one, because the logic going on here is pretty much the same as here. In this case, you're checking to see if the number of B's is equal to the number of A's. Right? And here you're doing pretty much the same. You're checking to see if the number of C's is equal to the number of A's. And well, let's figure out what's going on here. All right, so let's assume that you're in a branch. There'll be many, maybe. You're in the state Q3, and let's say there are several A's in the stack, and let's say there are 2 A's in the stack. Let's say, and you want to check that you now have 2 B's. Check that you have the same number. All right. So every time you get a B, you pop the stack. So you have 1 less A. Okay? So hopefully you'll pop the 2 now it could be that there are no C's. You could have a where is it? You could have this be 0. That's a possibility, right? So you just have A and B's. So if that's true, now let's see. So you read a B and you want to pop the stack. So you're popping an A. You're removing an A. So you're reading a B in the input stream. You read the A and pop it. Okay, and you don't do any writing, you don't do any pushing, so you just only pop. So in other words, if you have a non-epsilon here, arrow and then an epsilon, what's that doing? That's only popping, reading and popping. Okay, and if you have an epsilon here where the A is, arrow and a non-epsilon, whatever's here gets pushed. Okay, and all the other symbols in the stack get pushed down. Right? So in this case, what's going on? You're reading a B in the input string. You then pop. You look for the A at the top of the stack, and if it is you look at the top of the stack, and if it's an A, you pop it, right? And here you do nothing. You do no pushing. Okay, so you've just done a pop. Okay, so this looping here, every time you read a B, you pop an A. Right? Now, what's going on here? Well, if there's when you're reading the stack, and that's what the B position here, a bit confusing with A's and B's, but in the second position, after the comma here, if that's what's you're reading the top of the stack, and if that symbol matches whatever it is you have here, then do the action, make the transition. So in this case, what would happen? Well, say so let's say you've been through this quite a few times, and there's a so how can you get, because what's on the stack? It's only A's, well, besides the dollar, right? That's it. Okay, so once you've popped all your A's, you'll eventually get left with a dollar, right? So you ignore what's on the input string, you look at what's at the top of the stack, and if it's a dollar, okay, make the transition, don't do anything, don't push anything, okay, but make the transition. So you're now in Q4, that's an accept state. And then if you keep reading C's, it doesn't matter. You don't care, you just stay in that same state, because you've already succeeded, right? Because you found that the number of A's and B's is the same. So this branch, if you like, non-deterministically, is checking that the number of A's and B's is the same. Whereas this branch is checking that the number of A's and C's is the same. Now, I haven't got into all the details, but I hope I've given you enough on how to do it, right? So check the number of A's and B's is the same, and this branch is check the number of A's and C's are the same. And at this point, you make a split. In fact, a non-deterministic split. So you make two copies and so on. And you'll keep doing that at each step, I think, non-deterministically. Right. Yeah, this is a long session. Next example. So example 2.18 in the text. You're asked to find a PDA that recognizes the following language of these strings, where W is just, now that's star, so it's just an arbitrary binary string of any length. Okay, so W is any length binary string, zeros and ones. And the WR, if you remember, we've come across that I think once before. That WR, R stands for reverse. Okay. So, for example, if your string W was ABCD, then the W reverse would be DCBA. Right? You just reverse the order of the symbols in the string. Now this WWR, there's actually a word in English for that kind of string of letters usually. It's called a palindrome. P-A-L-I-N-D-R-O-M-E, palindrome. Like the pop group ABBA, A-B-B-A, that word is a palindrome. Or the programming language ADA, A-D-A, that's a palindrome. I'm trying to think of others. No, anyway, but you got the idea. So, you're asked to find a PDA that is that will recognize the language that consists of palindromes, WR, of where the W's are binary strings. Okay, so how would you do that? Well, the broad strategy is you'll do it non-deterministically. At each step, you'll do this sort of splitting kind of thing again, because you don't know where the division is between the W and the beginnings of the reverse W. You don't know that ahead of time. So at each step, split, non-deterministically, and at the same time push the next symbol in your W. And then once you've split, have it, and now you're checking whether the symbols that you're reading in match in reverse order, of course, with what's in your stack. But the stack is philo, right? First in, last out. So as you read the stack, you're reading it in reverse order. So that's to your advantage. In fact, that's probably why this example was chosen, because it's so suited to the use of a stack, right? I'll talk about the details of the state transition diagram for this example in the next session. This has been a long session.